Today on Daily Tech Hack Global, the story is not one single breach. It is a pattern across developer tools, CI runners, TLS validation, build caches, and deployment automation. The central thesis is simple: as AI assistants and agents move closer to code, cloud systems, and production workflows, the old line between a harmless project file and a powerful system action is disappearing. The question for today is, how do builders move fast with automation without letting untrusted repository content make security decisions for them? Here are the top stories for June 29, 2026. GitHub's reviewed advisory database shows a cluster of pnpm advisories. NVD lists recent critical entries touching Gitty act_runner, Node.js TLS hostname handling, JetBrains Kotlin build cache behavior, and Docker automation. SysA's public KEV JSON endpoint was not reachable from this cron run, so today's analysis is based on the accessible GitHub and NVD records rather than claiming confirmed active exploitation. That distinction matters. A vulnerability can be serious before it is known to be exploited, and defenders should separate confirmed facts from risk analysis. First, pnpm. The GitHub advisory feed includes several reviewed pnpm advisories published in the last cycle. The summaries point to path traversal, package manager selection, patch removal, manifest identity, and install or staging behavior. I am not going to walk through exploit steps. The defender level point is more useful. pnpm sits at a highly privileged point in modern software delivery. It runs when a developer installs dependencies. It runs inside CI. It may run in ephemeral containers. Increasingly, it also runs after an AI coding assistant suggests a fix, updates a package, or tells a user to reproduce a build. That is where the AI security angle is real, not forced. The problem is not that every coding assistant is unsafe. The problem is that assistants compress decision time. A human may see a repository, skim a README, accept an install command, and miss that project metadata, scripts, patches, or log files can influence what the package manager does. An agent may do that at machine speed. If repository-controlled content can steer install behavior, path handling, or command execution, then the agent needs guardrails before it touches the terminal. Approval prompts, restricted workspaces, disposable containers, and reduced environment variables are not productivity theater. They are the controls that keep automation from turning a project file into a broader system event. The second story is Gitty act_runner, listed by NVD as CV 2026-58053. The accessible NVD description says Gitty act_runner with the Docker backend passes a workflow container option string into Docker job container host config, and the concern is especially important when privileged containers are involved. The safe explanation is this: CI runners are translators. They translate repository workflows into real container operations on infrastructure. If the runner lets a workflow influence dangerous container settings, isolation can weaken. For organizations that use self-hosted runners, the checklist is clear. Patch according to vendor guidance, separate trusted and untrusted jobs, avoid privileged Docker unless absolutely necessary, rotate runner tokens, and assume a compromised build job should not be able to reach cloud metadata services, production secrets, or the host file system. This is also an AI agent issue. Many teams are experimenting with agents that open pull requests, run tests, triage failures, or operate within repositories. That can be extremely useful. But if an agent can trigger a workflow on a self-hosted runner, the runner is part of the agent's effective permission set. Security reviews should not stop at the model prompt. They need to include the runner configuration, network access, secrets exposure, artifact permissions, and which repositories are allowed to trigger privileged jobs. The third story is Node.js TLS hostname handling, listed by NVD as CV 2026-48930. The MVD summary describes a flaw in TLS hostname handling involving embedded null hostnames and authority rebinding due to string truncation in resolver bindings. Again, the practical lesson is higher level than any exploit detail. Hostname validation is one of the places where software decides, silently and quickly, whether the remote service is who it claims to be. That decision protects API clients, package fetches, webhooks, command line tools, cloud services, and agent systems that retrieve remote content. If validation logic can be confused, the result is not just a browser problem. It can affect backend automation and service-to-service communication. For defenders, the response is to track Node.js runtime advisories, update supported runtime versions, and inventory where Node is used outside obvious web apps. Look at build tools, internal CLIs, serverless functions, bots, integration workers, and agent tools. In many companies, Node is not one platform. It is a utility layer spread across the business. That makes runtime patch management a governance issue, not just an application team issue. The fourth story is JetBrains Kotlin, listed by NVD as CV 2026-53914. The accessible description says that before Kotlin February 4, 20, code execution was possible through unsafe deserialization in build cache metadata. The concept defenders should remember is provenance. Build caches exist to save time. They reuse outputs and metadata across machines and pipelines. But when cached metadata is consumed by a build process, the system needs to know where that metadata came from, whether it can be trusted, and what parser or deserializer will handle it. Speed is valuable, but fast reuse without trust boundaries can move risk across developer machines and CI systems. The fifth story is Doku, listed by NVD as CV 2026-54636. NVD describes an issue involving the Doku cron plugin and commands in app configuration used to manage system cron as the Doku user. The defensive takeaway is familiar but important: deployment automation is code execution with a calendar. Cron hooks, app manifests, GitHub actions, package scripts, and infrastructure as code templates all sit in the same family. They convert text in a repository into action on a machine. That means they need least privilege, review, logging, and separation between application authors and platform administrators. Put the stories together and the pattern becomes obvious. pnpm advisories focus attention on package managers. Git-act_runner focuses attention on CI isolation. Node.js TLS focuses attention on identity validation. Kotlin build cache focuses attention on deserialization and provenance. Doku focuses attention on deployment hooks. Different technologies, same operating surface, automation is now the connective tissue of software delivery. So what should teams do today? Start with patch triage, but do not stop there. For pnpm, identify where it is installed, upgrade according to official guidance, and treat lockfile, patch, manifest, and package manager configuration changes as security relevant. For AI coding assistance, require explicit approval before install, build, shell, network, or file system actions that go beyond reading and editing code. Run agents inside disposable workspaces with minimal secrets. Never give a broad cloud token to a general-purpose coding session. For CI, divide runners by trust level. Public pull requests, internal repositories, release builds, and production deployment jobs should not all share the same runner privileges. Disable privileged Docker by default. Restrict network egress. Avoid mounting sensitive host paths. Keep short-lived credentials short-lived. Make logs searchable enough to answer which workflow ran, which commit triggered it, which secrets were available, and what artifacts were produced. For TLS and runtime risk, inventory language runtimes as infrastructure. Many incident reviews miss the fact that a vulnerable runtime can live in build scripts, bots, integration workers, and one-off automation. For build caches, require trusted cache sources and avoid sharing high-trust build artifacts with low-trust jobs. For deployment hooks and cron plugins, assume that any configuration capable of scheduling a command needs code review and platform-level limits. The payoff is this: security teams do not need to ban AI agents or developer automation. They need to make the blast radius visible. A good automation design can answer 4 questions before anything dangerous happens. What input is being trusted? What action will run? What credential will it use? And what system can it reach? If the answer is unclear, the action should pause for review. What should you watch next? Watch for vendor patches and postmortems around the listed advisories. Watch whether developer platforms add stronger defaults for agents, package managers, and CI runners. Watch whether security products start modeling agent tool calls as identity events. Most of all, watch your own pipelines. The next major AI security incident may not look like a model breaking a rule. It may look like a normal automated workflow doing exactly what an untrusted project quietly asked it to do. The conclusion is practical. The future of software will include more assistants, more agents, and more automated delivery. That future can be safer than today's manual chaos, but only if teams pair speed with verification. Patch quickly. Segment runners. Reduce secrets. Review automation hooks. Treat project metadata as input, not authority. And make every agent, build job, and package manager prove what it is about to change before it changes the world around it.